OSPF show commands reveal a lot of information about what the OSPF designated router does. We'll start this next video looking at those details, and then we'll disable the use of a designated router and see how those commands change. This video gets into the detail from the command line interface about how you can observe the use of the OSPF designated router. And that choice on a Cisco router is chosen by the default setting of being a broadcast network type in a Cisco router. So we'll see that. We'll look at all those show commands. Now it assumes you would know the theory of what a DR is, a designated router, based on the first of the two instructional videos that are associated with the CCNA Cert Guide Volume 1, Chapter 23, Section 1. Now, once you see those two instructional videos, I've got a couple of review activities lined up for you, a config lab and an ad hoc lab. So make sure and check out the related videos there as well. I'll tell you about those at the end of this video. So at the end of the video, as always, I'll talk to you about how do you use the books effectively, knowing that you've already learned some or maybe all of the content from here in this video. I'll tee up those review videos so you know where they are and how to best use those. And then I'll give you a little extra. This time it's a little bit extra study and review content. All right, thank you for all the support and encouragement you've been giving me. Continue to do that. It really does help. Even something as simple as just clicking like right now is a big thing. And when you're ready to buy products to learn more about CCNA, if you start at that link, I'll make a few extra bucks as paid by Cisco Press or Amazon, for instance. All right, folks, thanks. Let's jump in and look at some show command output. Now let's look at the show command output mostly of what happens with a DR. We've got our same four routers with R4 as the DR and R3 as the BDR and R1, R2 as druthers. So if we focus first on router R1 and we do a show IP OSPF neighbor command to see its three neighbors, it is neighbors with three routers, but notice its neighbor relationship with router R2, it stays in a two-way state, as I just mentioned, and it mentions druther here in the output. Now, this command lists information about the neighbor. So this druther reference is R2's state as druther. Because note in this line about router R3, it says full state. We're in a full state with the backup DR. And the backup DR's state is backup DR. And in this last line, full state with the DR, there's its state of DR. So in this show IP OSPF neighbor command output, it's the other router's state that we see in the state column and our relationships state, two-way or full, depending on our role and their role. Now to flip that around, let's look at router R4 next. In this next page, the output is from router R4, which is the DR. So it will reach a full state in all three of its neighbor relationships because it needs to exchange LSAs with every router. But notice it identifies the DR other state of neighboring router R1 and neighboring router R2 in those first two lines. But with the BDR, it mentions the BDR state of the other router R3 in this third line. So that's how you interpret the most important parts of show IP OSPF neighbor in this case. Now on the flip side, the show IP OSPF interface brief command tells us more information about the local router. So here we're back at router R1 and we do this command, and as a reminder, it's the gig 000 interface on each router that's connected to this common subnet. So focusing on gig 000 for a moment, we see that it lists DR other. So that's the local router's state on this interface. It's not talking about a specific other neighbor. It's talking about this router. So it's saying R1 is a druther. And then we get some really interesting counters that I want to spend a few moments with. Notice this 2/3, and it's under the neighbors F/C heading. So that's neighbors, fully adjacent, and total count. Fully adjacent, total count. So remember the R1 output from a few moments ago? It was adjacent with three total neighbors, two of which it had a full state with the DR and with the BDR, and that's what the two is. Number of neighbors with which I'm fully adjacent, number of neighbors total is the output here. And I'll contrast that then. By the way, there's the counts over there in text. If I do the same command over on router R4 this time, it's the DR, so it's going to be in a full state with every neighbor. So again, on its gig 000 interface, its state is DR, so it lists a DR under the state heading, and it says 3 and 3, the first 3 meaning 3 fully adjacent neighbors in a full state, and 3 total neighbors. Now, if you use that same command without the brief keyword at the end, you get lots more detail. So we'll start here on router R1, and we see lots of information about router R1's interface gig 000 that's on this common subnet up here in the middle. So what do we see? We see network type broadcast. That's the default network type for OSPF on an Ethernet interface, and that type is what tells OSPF use a DR. All right, if it was another type, it may not use a DR, right? But that's the type that triggers the whole use of a DR. We see that this router R1 is DR other off that interface. It identifies the DR and BDR by router ID. It identifies those counts we just talked about, just in longer form. And it identifies the fact that this router is fully adjacent, that is in a full state, with 2 neighbors, 3333 and 4444, which are, of course, the BDR and the DR. Now, if I do the same command over on router R4, we get a little bit different output. Same types, but a little bit different specifics. It's using the default network type of broadcast, but in this case, the router is the DR. It still identifies who the DR and BDR are, as we see there. And we see its neighbor count is 3, but its adjacent neighbor count is 3 because the DR becomes fully adjacent with every other router. There are 3 other routers in the subnet, so it's got 3 fully adjacent neighbors, which are listed on individual lines down below. 2 of them are DR others, and there's nothing out to the side on those, but the one that's got a special state of backup DR, number 3 here, is mentioned there in the output. All right, one last command before we move on. If you want to change the interface priority, which I suggest you do in lab a little bit later, you just get into interface config mode and configure their priority. Higher number is better. In this case, we've changed it from the default of 1 to 14. So next time there's a general election, this router's got a better chance of becoming the DR. And if you do a show IP OSPF interface command, the long version like we just went over, and search for the word priority with a capital P, you'll see the priority mentioned in there. One last short topic to wrap up. I mentioned that the OSPF network type of broadcast is the default on Ethernet interfaces. So what does that mean? That means it's directing OSPF to send hellos to discover neighbors, but then to use a DR and BDR. There's several other OSPF network types. The only one mentioned for CCNA is called point-to-point. And in that case, you send hellos to discover neighbors, but the routers then, once discovered, send LSAs directly to each neighbor. And it's intended for cases for which there are just 2 routers on the link, typically, say, in a WAN link. So if there are 2 routers, it's actually more efficient with faster convergence if you change to use point-to-point. So when might that be the case? Well, here's a classic case. If you've got an Ethernet WAN link and you know there are only 2 routers on that Ethernet WAN link, the default would be to use broadcast type and a DR. That's less efficient. Change it to use point-to-point. All right, so how do you do that? Well, let's take a look. First off, to confirm that it's using broadcast type, the show IP OSPF interface command, you look for the word type and it tells you the type. So that's where you're visually scanning or you're using this command to search for it. So you look there. Then you're going to expect, when you look for neighbors that are off that interface, to see the neighbor state / DR, BDR, or DR other in the output. And then in your show IP OSPF interface brief command, you should be expecting to see states like DR, BDR, and DR other, right? So that's our default operation that we just saw. Now, if instead you go to both routers on both ends of the link and change to say, I want to use point-to-point, here's how, interface whatever, IP OSPF network point-to-point. If you change one side to point-to-point and leave the other as broadcast, it won't work. The neighbors won't form. But if you do this, both ends point-to-point, you'll have neighbors, and things will work just fine. You'll see the network type change there in the show command output, just like you would expect, but a few other details in the show command. Now that we've made a change, we see network type is point to point. In our show IP OSPF neighbor command output, we still see the neighbor state is full, but out here where you would normally see DR, BDR, DR other, there's nothing except a dash. And that dash is meant to be a reminder, hey, we're not doing a DR here. All right, so that's the style that you want to look for to say, oh, it must be point to point. And then over here in the show IP OSPF interface brief command output, P2P for point to point. So let's talk about the exam. If you've got the official cert guides from Cisco Press and you're looking at volume 1 and you open to chapter 23, the first section, you'll find the same topics you saw in this video. So I've got 2 videos here about the topics in that section. You see their titles or topics over there on the right. If you watch both the instructional videos, then you could skip the section of the book. All right. So I'm telling you, you've got freedom to do that if you want to. Pick up some time, get a little bit of a break. That's fine. It's always useful to also read the book section. It just gives you an alternate view of the content because I approach things differently in video versus in writing. But there aren't really any particular things inside the section that I'm thinking, oh, you just really need to reread this after watching similar things in the video. Okay, so you can be pretty relaxed about this if you watch both videos. But you should practice and review. So I've got 2 of those activities lined up. First off, a config lab, which for me means there's a blog page that describes the lab. There's the URL. There's a link in the description. There should be a link above you in a card that's appeared. And on that page, you'll find a lab intro that tells you the topology and initial config. Then it says, go do the lab. And then it reviews what I think the right answer should be. In addition to that, there's a lab intro video and a lab review video here. If you want to go a little deeper, these videos do go a little deeper than the blog page, but you should do the lab. I would encourage you just to start there with the blog page that you see. I've also got what I call an ad hoc lab. With ad hoc labs, there is a video and no blog page. So you should open up the video. Again, there should be a link that's appeared or a card that's appeared at the top of the screen. There's a link in the description. And in that video, I'll set up the lab. There'll be a lab intro. I'll ask you to go do the lab, and then I'll review and demo the lab there. So what's that lab about? It's about practicing designated router elections. So it's really about the theory in the first instructional video about why does which router become DR and BDR. But I wanted you to get some CLI commands and the configuration commands, particularly priority, under your belt before launching off to do this lab, so you know what commands to use in order to do that part of lab. Hey everybody, thanks for hanging out. Give me a like, give me a comment, give me a share. Those are the best ways you can help me out and say thanks and help me do better at the channel. As always, if you're new, welcome. Click subscribe and the bell so you get notified about the new videos. Talk to you soon.